All right. Hello, everyone. This is Volts for November 21st, 2025. Clean electrification is inevitable. I'm your host, David Roberts. Way back in 2021, I had energy analyst Kingsmill Bond on the podcast to discuss his optimism about what he calls electrotech, the cluster of technologies, including renewables, batteries, heat pumps, EVs, digital control systems, that is enabling the global shift to clean electrification. Since then, Bond has moved from Carbon Tracker to RMI to the research firm Ember. And in the meantime, events have only bolstered his optimism. In September, he and his team at Ember released the Electrotech Revolution, a report and an absolutely riveting slideshow arguing that we are on the cusp of a fundamentally new energy age. Quote, a century of evolution is converging into a decade of revolution. We are experiencing simultaneous revolutions in the way we generate electricity, the way we transport and store it, and the way we use it. Fundamental physical, economic, and geopolitical forces have rendered these revolutions inexorable and irreversible. Or so the report argues. By the way, it's almost a shame to cover this report on a podcast, since it really is quite beautiful. Any lover of charts and statistics should check it out on the web. I am thrilled to have Bond back with me today to discuss this revolution, its drivers and consequences, why it is unstoppable, and what we can expect to see in the next decade. With no further ado, Kingsmill Bond, welcome back to Volts. Thanks for coming.
Thank you, David. Glad to be here.
Kingsmill, I'm so thrilled about all this. I've got so many questions. This whole report might as well be like a mission statement for Volts. This is what Volts is all about. So I was just wallowing in these slides, absolutely loving it. But let's start here. One of the things I think, one of the services you're doing here, even aside from all the data and information, one of the services I think you're doing is just giving this cluster of trends and technologies a distinct name and identity. Talk about how you distinguish electrotech from clean tech or climate tech more broadly.
I should start off by saying that the name was invented by my colleague Dan Walter, but...
Well, thank him then.
Kudos to him, exactly. But what we're trying to do here is we're just trying to... Carlota Perez, a Venezuelan academic, talks about technology clusters coming together. And we just wanted a way to describe, as you said earlier, the fact that these new technologies are coming together around the electron. And the reason why electrotech and not clean tech is, I think, clean tech is a kind of wider or slightly different definition and slightly tarnished because it had pulled into the mix lots of technologies which simply don't have learning curves and don't have the efficiency characteristics that we talk about, and also are not cheaper. So, for example, biomass or carbon capture or hydrogen, these are not really electrotech technologies. And we wanted to focus on winning solutions which enjoy the drivers of physics and economics and geopolitics. And that's why we focused on electrotech.
Right. So this is a subset of clean tech, you might say, a specific subset of clean tech around the electron.
Yeah, exactly. The key point is that by calling a name and pulling it all together, we can draw into the tent AI, which I'm happy to argue is a very clear electrotech technology.
We'll get to that later.
We bring in batteries and so on and so forth.
Right. And the other thing I think is useful, one is just to distinguish this particular subset of clean tech, but another, I think, is losing the clean thing and replacing it with electrotech, I think is also a reminder that I think is really important that I'd love to hear you talk about for just a minute, that the trends and technologies involved in electrotech precede any concern about climate change, or rather the large-scale trend toward electrification that is sort of pulling all these clusters of technologies slowly together, that trend way predates climate concern, way predates anything clean. This is something that is going on regardless. So just talk a little bit about the history angle.
Sure. So look, I mean, as your listeners will know, electrification has been going on since 1880. And the United States was famously responsible for half of all global electricity demand in the 1930s. So it was an absolute global leader in electrification in the past, and I suspect it will be again. But yeah, these are technologies which have been growing for many decades. I think what's interesting is that it's only really in the last few years that a lot of the technologies have crossed key cost tipping points where they can challenge the incumbency on cost. And when you get cost tipping points and volume, that's when you get very exciting things happening.
Yes, but I just want to drive home the point that the merits, the advantages of these technologies, economically, physically, et cetera, stand apart from climate concern. Like, it is good that they're reducing emissions, for obvious reasons that we agree on. But I think more or less all of this would be happening regardless. Don't you think? Just because of this better technology.
Yeah, exactly. So, I mean, these technologies, as I say, being our concern about climate, they've been driven by the laptop and the iPhone in recent years are absolutely massive drivers of our capacity to get cheap batteries and cheap solar panels. Solar panels much more in common with a laptop, for example, than it does with a barrel of oil. So these are technologies which, to a large degree, are kind of spin-offs from the tech sector.
Yeah, I think that's so important to understand. It's easier to understand this stuff as sort of the next chapter of the digital technology revolution rather than the climate technology revolution. That makes more sense of them, I think.
Yeah, and so what are we doing? I mean, electricity, by definition, is a digital technology, whilst fossil fuels are analog. And we're digitizing our energy uses. AI is the electrification of thinking. And the more we electrify and digitize and create flexibility, the more we can use the resources. Again, it's all got a lot in common with the way that the tech revolution evolved. I mean, I should say, I have a background as I was a tech analyst back in the 1990s, so they're very familiar territory for me.
So just briefly, before we jump into the dynamics, let's just talk a little bit more fully about what technologies we're talking about. So as you say, there are these clusters converging, and you cite three clusters. There's renewable electricity supply, electrified demand, and digital coordination. So just briefly describe what those three clusters are and kind of what the convergence is.
I guess the first point is that what is unifying all of these clusters, apart from the electron, is that they are modular and small and on learning curves. And that, again, sort of narrows down the sphere of options for you. So in the supply side, the two standout technologies, where we are, of course, very ecumenical, anything could join the tent, but the two standout technologies which do work are obviously solar and wind. And the demand side, the standout technologies are electric vehicles and heat pumps and the electrification of light industry, particularly in China, which is a very, very big thing right now. And then I think the messy middle is probably the most interesting. That's probably the area where it's going to be the most amount of innovation. Your friends from Piccolo, for example, or Octopus, or the incredible innovation that's going on, battery storage, AI we're already claiming as a kind of connection technology, but you've all kinds of software solutions, and then you've got better cables and HVDC lines. Again, all the great folks are on your show, David.
Yeah, it's all painting one big picture. So you got new, better supply technologies, electrified demand technologies like EVs and heat pumps, and then all this digital stuff, all this software to coordinate how the supply matches up with the demand. So that's electrotech. And so what I think is the most important part of the report, the part I enjoyed the most, is just this first bit about fundamental drivers, because I really think understanding these three fundamental drivers is so crucial for understanding the energy world right now and understanding why, despite short-term fluctuations in this or that market or this or that country or this or that specific technology, the sort of long-term arc here is inevitable. And I think understanding these drivers helps you understand why that is so. So let's go through them. The first is physics. I love this point. This is a point that I bang on all the time on the pod. I think Saul Griffith was the first person to make the point on the pod, which is just the simple point that electrotech is more efficient than fossil fuels. So just talk about that for a minute. What does that translate to? What does that mean?
So in simple terms, it means you can get 2 or 3 times as much useful energy from electrotech solutions as you can from fossil solutions. And at the moment, we have this remarkably inefficient system. You put into the factory, as it were, at one end, 600 or 650 exajoules, and you get a round of primary energy, and you burn it. And as you burn it, you have these enormous inevitable thermodynamic losses of between 40% if you're a coal-fired power station, or 50%, or if you're a car, about 75 or 80%. You just can't avoid this stuff.
A car is the worst of all. It's amazing how little of the energy we stick into cars ends up actually moving them.
So we're pouring, from our calculations, basically 2/3 of the primary energy into the air and wasting it.
Yeah, this is one of the facts I want to put on a t-shirt, Kingsmill, because this is like something that people in our world, I think, are familiar with at this point because they've heard it so many times. But this is something that blows people's minds outside our world when they hear it for the first time, which is that 2/3 of the energy we dig up out of the ground in raw form is wasted. That is just mind-blowing. And it's probably not mind-blowing to you anymore. You're so used to it, but I think that blows people's minds. We are wasting 2/3 of the raw energy we have access to. And basically moving to electrotech doesn't eliminate waste, but it radically reduces it.
Yeah, I mean, your waste levels are going to be around 10%.
Right.
Again, it depends how you structure it. But if you think about it, just think about it for a second from first principles. If you want electricity and you have a house in Japan, for example, you can pay somebody to frack the ground in the middle of America, get the gas out, pipe it to the coast, freeze it, put it on a boat, bring it to Japan, unload it, unfreeze it, bring it to
put it in a pipeline,
burn it, lose another 2/3 of it, turn it into electricity and get it to your house. You can do all those things. That's great. Or you just buy a single solar panel, stick it on your roof and get exactly the same electrons. And that's the point. I mean, it's just dramatically inefficient, the kind of fossil fuel system. And we, being finance folks and very focused on the numbers, we calculated that's $4.5 trillion of lost energy.
Jesus.
And it's also a $4.5 trillion opportunity for entrepreneurs such as Piccolo to aim at. And the point is that for decades, we had no other solutions. We couldn't come up with anything better than fossil fuels. But now we can. And that's the exciting point.
Yeah, and I love you cite Amory Lovin's distinction between obedient electrons and fiery molecules. And I think that's so important to understand. Just electrons are more manageable. Like they're digitally manageable. You can move them around in precise ways. Whereas when you're burning stuff, like the molecules fly all over the place. You can't, there's a limited amount of control you have over your fiery molecules. So like electrons are always going to be more tamer, let's say.
They are tamer. And the big problem with electrons in the past was, first of all, they were very, very expensive. And, really until recently, like you go back to the start of electrification. Well, obviously the start is zero, but, even right through to the 1930s, 40s, electricity on about 5% of final demand. This stuff is really expensive, or was. And also the big problem with it, we sort of solved the cost problem. But the other massive problem with electricity always was you couldn't store it. You couldn't store it, have instantaneous supply and demand everywhere at all times. And that's why we're so excited about this convergence of technologies, because suddenly you've got these batteries coming through, $100 per kilowatt hour is the number everyone's talking about right now, but they're doing it for 60 in China. And you can store this stuff now. And we're just scratching the surface of what that means.
You guys have got a new piece up on Ember that sort of frames this as like an agricultural revolution. Like for the first time, we have granaries. Like imagine global agriculture. If you couldn't store grain, you just had to eat it out of the fields. You had to time it to meet everyone's hunger in real time, right? Imagine the revolution of like being able to store grain. It just absolutely changes all the systems and all the system dynamics. And that's roughly what's happening in energy. We have granaries now.
Yeah, I mean, you have it there in the Bible. Joseph and his Technicolor Dreamcoat, all about granaries. An even more powerful analogy and more recent is refrigeration. So until refrigeration, food rotted in the supply chain, and then around 1900, refrigeration comes along, massively resisted, I should say, by the ice industry, with great lines saying that ice is better for you.
I know, and all those ice jobs lost.
Yeah, so then refrigeration comes along and it creates a whole new industry. So suddenly Argentina can supply Europe with meat. Suddenly you don't need massive milk trains taking huge amounts of space outside New York because they have to all come in by 6 o'clock in the morning. And you have this obsolete infrastructure. So you can kind of see where I'm going with this kind of analogy that the capacity to store electrons is just going to completely change the rules of the game. And as I say, we at the moment have around 400 gigawatt hours of storage to 4,000 gigawatts of solar and wind. It's completely feasible that within 20 years, we'll have 2 or 3 times as much storage as we have renewable capacity.
Yes. And one of the things I always say to people just to spark their imaginations is just sort of imagine what an electricity system will look like when it doesn't matter where and when you're producing your electrons, when we have enough storage that we have rendered that basically irrelevant. Anybody who understands how the electricity system works, that's a real mind blower. And one point I wanted to make in this, under this particular heading of physics, is that, you said this earlier, but it's important to distinguish. This is not true of green tech more broadly. It is specifically electrotech that has this feature of being intrinsically much more efficient. It's not true of like biofuels or hydrogen.
Yeah, well, hydrogen, as everyone knows, is basically the most expensive form of electron because you have to turn it into hydrogen and then back again. But actually, I want to talk about biofuels because biofuels are absolutely fake solution to the climate problem.
They go the wrong way on efficiency.
Right? I mean, it's a joke. Like the efficiency of biomass is sub 20%. You're putting in 20 exajoules or you're putting in 100 exajoules of biomass in the front end of the machine and all you get out the end is 20. What a waste.
I know.
It's a spectacular waste. And it's even more of a waste when you think about biomass conversion efficiency of sunshine. You put biomass in a field and it's well, as you know very well, David, it's collecting less than 1% of the sunshine. And then you're wasting half of it in the whole conversion process. And a solar panel in the same field is going to collect 20%. Shameful.
Yes, people complain about the land use of solar, and I just say, look, why don't we take, call it a fifth of the land the U.S. uses to grow corn for frickin' ethanol, hand that to solar, and we can power the whole country off it. Another point I wanted to make, just distinguishing electrotech in the physics sense from the larger green tech, another sort of quasi-efficiency argument people sometimes make against this stuff is about materials efficiency. I've been over this on the pod before, but there's a great chart in this slideshow just comparing materials use. So just briefly compare the materials efficiency of electrotech versus fossil fuels.
The key point about fossil fuels, and it's very obvious, but it bears thinking about, is that
people miss it. People don't think about it. It's worth pointing out.
Sure. I guess what we specialize in, the kind of pretty obvious, but you have to be numerate. But it is that we're burning 16,000 billion tons of fossil fuels every single year. And then you come back and the next year you burn it all over again. And in contrast, the entire build out of electrotech solutions would require a fraction of that in order to build the infrastructure. I mean, we're talking like a billion tons. That's it.
Yeah, and I do think it's fair to say that just constructing the generator, if you just look at the amount of materials to construct an electricity generator, you are using more materials per kilowatt output for solar than you are for a natural gas power plant. But then, as you say, when you've constructed the solar plant, you're done spending money. The fuel rolls in for free forever from then on. After you construct the natural gas power plant, then you got to buy natural gas every day for the rest of your life. So like that is material. Natural gas is material. That is digging, that is disruption of the landscape, et cetera, et cetera. So that counts as material. And if you count the like fossil fuels you have to dig up and burn, it's just wildly more materials, mining, disruption, transport, et cetera, wildly more in a fossil fuel system.
Yeah, I mean, actually, in the particular case, I remember I did the calculations a few years ago. If you do solar versus coal over the lifetime of producing electricity, it's 2,000 times as much stuff from solar panels versus a coal plant. Because like coal's very, very heavy and you can only use it once.
Yeah.
Incidentally, the latest IEA WEO is out today and it has its advantages.
That's the World Energy Outlook.
World Energy Outlook. And it has its advantages and disadvantages. But one of the things that they did in that is they looked at an issue which we often get as pushback against this argument that fossil fuels are very heavy. People say, oh, but minerals require lots of ore. And the IEA actually did the calculation and they said, look, coal and oil also require lots of rock and stuff to be moved. And when you do the total calculation, they worked out that the total amount of stuff that needs to be moved for the fossil system is about 100 billion tons versus about 10 billion tons for all of the minerals, for everything.
Yes.
So again, I mean, that particular fake argument which we had coming down the pipe, that's also not true.
Yeah, it's very dumb. And the other important fact that you note in the report that's worth pointing out is once you dig the materials to build a solar panel out of the ground, you can recover them from the solar panel. So we have, at least in our line of sight, something like a closed loop where you're done digging, where you have the materials you need and you're just recycling them again and again, which is not something you're ever going to get out of fossil fuels.
Yeah, I mean, and this idea of continuously recycling valuable minerals, it does require a bit of a change in mindset because we're so used to just chucking stuff out. But if it's valuable enough, and of course, some of these minerals are very valuable, then that's what you're going to do. I mean, I'm sure you've had the folks from Wedgwood on the pod.
Yes.
That's what they do. They take these valuable minerals, they recycle them. And of course, let's imagine you're losing 10% in that supply chain.
Right.
If,
sure.
Of course, over 15 years, you get 10% efficiency gains, then effectively you're recycling these minerals or the use of these minerals forever, because the next time you build a car, it's going to be probably actually 40% more efficient. And therefore you can do with 40% less minerals.
Right. So your efficiency gains are keeping up with your materials losses.
Yes.
And you get to a closed loop.
You get to a closed loop.
Which is like never something that is ever going to be possible with fossil fuels. Okay, so this is physics. These are three fundamental drivers. The first one is physics, which is just electrotech is intrinsically much, much, much more efficient, much, much less waste, much, much less disruption, material, transport, et cetera, et cetera. Pick your metric. It's just a lower lift and more power with less digging. So that's the physics. And this is, we should say, I've hit this point on the pod a couple of times. We had Michael Liebrich on. He, at this point, I think Saul Griffith at this point, you often see these primary energy comparisons. I'm sure you're very familiar with them that show that out of the primary energy entering the economy, only a tiny sliver is renewable. But of course, that is deceptive for precisely this reason we're talking about. Clean electrotech doesn't have to replace that whole chunk. It only has to replace a third of it. The third of it that's actually going to useful energy, we don't have to replace the waste, right? So the target is much smaller than that graph makes it look.
Yeah, your target is basically 3 times smaller than it looks. It's also a kind of fake argument that, you have to replace everything. Of course, you don't replace everything overnight. And one of the very first things they teach you in finance is you don't think about the size, you think about the growth or the acceleration even. And that's the point, is that these technologies, you don't want to look at their size. You want to look at the share of the growth they're taking. And that's the exciting point, is that, we're already basically taking 90% of the growth in electricity generation. We're taking, I hesitate to say this, but certainly by the end of this decade, we'll be taking all of the growth in final energy demand as well, be coming from electrotech. So, folks, we're there. We're eating your lunch right now.
Well, that's a good segue to the second fundamental driver here. The first is physics. The second is economics. And the basic insight here, which again, if it hit on the pod many times, is electrotech specifically. Those technologies are on learning curves, which mean they get cheaper as they scale, and fossil fuel doesn't. Like, I think another thing that's sort of remarkable to people who are not familiar with this stuff is that the sort of inflation-adjusted prices of fossil fuels today are roughly what they were 100 years ago, 200 years ago. And that's not true of electrotech. Like, electrotech goes down. So talk about why that is so.
In its very simplest form, it's technologies versus commodities. Technologies have
exactly.
They have the capacity for people to innovate, particularly if they're small and modular. And as they get bigger and more people get involved, then there are more brains and areas of talent figuring out ways to reduce costs and make it better. And as a result, costs fall over time. And as they get bigger, they get cheaper. Now, with fossil fuels, of course, it's the opposite. As you extract the cheapest stuff first, as they get bigger, there's a constant pressure for costs to rise because you have to go further and further offshore and deeper.
Yeah, digging farther and farther down, you're going to more and more extreme environments. So that is, all things being equal, pushing the price up.
Yeah.
And of course, fossil fuels also have technologies involved, which are pushing the price down. So that sort of upward pressure and the downward pressure, more or less over time, balance out, which is why the prices are like, even though they fluctuate a ton in the short term, they're like eerily steady over long periods of time.
Yeah, and actually, I mean, nobody can really explain why this is the case. It's just happened the way it is. It's precise uses, lots of innovation going on in fossil fuels, but it's balanced by the fact that you take cheaper stuff out first. And net, the price in 2025 is roughly what it was in 1900 or 1925.
Yeah, that's just wild to me.
Yeah, and can you imagine the solar panel back in 1976, $100 a watt? Now it's 10 cents a watt.
Yes. Yes, because the sun notably does not get harder to get the more you harvest it. It just remains just as easy to get, on the 5 millionth unit as it is on the first.
And I think, David, you were saying to Michael Liebreich on your pod that, you need inspiration in this world. But this is surely the most inspiring thing, that we can use live sunshine, which gives us as much energy in 5 days as the entirety of all fossil fuel reserves, which is dead sunshine or fossilized sunshine, can do if you burn the whole lot. I mean, that's extraordinary. And we have this incredible opportunity to harvest the sun live every day. And then store it in batteries every night and wake up the next morning and do it all over again.
I think because of the association of climate tech with environmentalism, people still associate it with efficiency and doing less and sort of like pulling back our aspirations and becoming smaller and degrowth, all that stuff. But I think, for very obvious reasons that we're talking about here, like if you have big, grand ambitions for humanity, you don't just want to like 2x the amount of energy humanity uses. You want to 5x it or 10x it. You want to like desalinate the oceans and go to Mars, all these big things. You simply physically can't do that with fossil fuels. They're just, you're going to reduce your home to a cinder and burn all the fuels before you can get there. The only way to do really big, futuristic things is with the sun's energy. That's the only source big enough.
Yeah, and this is again why, it is exactly as you say, it's 100-fold increase in potential energy capture just by harnessing the sun. And that's why, for me, the best analogy to what's going on here is the kind of biomass to fossil transition of 200 years ago. And, then the other one, of course, is famously, as Ian Morris says, is the kind of hunter-gatherer to farming transition of 10,000 years ago. Nobody remembers that, no data for that. But, you can kind of get the point. Every time humanity kind of stumbles upon or finds or innovates a dramatically better way of harnessing energy, a lot changes.
Yes, a lot of growth. So a couple of questions about these economics, the learning curves. One is just, and I think this is a question everybody has, which is like these learning curves, there's something a little bit sort of almost supernatural about them because, like you just look at solar, like what are the forces that are making solar cheaper? Well, it's not one thing. It's like some research over here. Germany passed these laws. China invested this money. It's a grab bag of things. And yet the net outcome is this eerily consistent drop in prices every time global deployment doubles. And you're seeing the same thing with all these other technologies. And I guess it's just like there's something almost like eerie about it. And I guess one of the things everybody wonders is, are these learning curves going to continue? Are they going to go on forever? Like, do we know anything about whether there are limits to these things?
To answer your point about whether it's eerie or not, I mean, don't forget, we've been living with a famous learning curve, which is Moore's Law, for decades. And nobody ever says that's particularly eerie.
I think it's eerie.
But it's really cool.
It is kind of weird.
It's just really cool. We just run with it. I mean, the world expert in this stuff, of course, is Doyne Farmer in Oxford. And, he makes a very good point. He just says, look, we do not know where the innovation will come from, but we can be very confident that small modular technologies, once they get onto a learning curve, it keeps going for a very long time. So, if the great hope of the fossil fuel system is, and you see this incidentally in the IEA's World Energy Outlook this morning.
They're still doing it?
Articulate. Yeah, they're still doing it.
They're still doing it?
Still doing it. Still flat solar. It's kind of embarrassing. But anyway.
I know. It's not like they haven't heard the critique at this point.
Yeah.
Well, anyway, we should say what we're talking about. So, the listeners are very familiar with official predictions of the price of these electrotechs, like solar panels. And what the official predictions say over and over and over again is that the price is going to plateau, that it's going to stop falling and plateau. And they have been saying this, Kingsmill, as you know, over and over every year.
For about 20 years.
Decades now.
Yeah.
And at this point, they've heard the critique. The predictions are so theatrically wrong over and over again. It's not like they haven't heard feedback. It's like they've seen that they're wrong, and yet they keep doing it. And this is speaking of mysterious to me, this is mysterious. What is going on with that dynamic? Is it just that if you take the learning curve seriously and just draw the line so that it keeps doing what it's doing, you end up with some really crazy pants projections that sound crazy and utopian, I guess. I think that's what scares people off. What do you make of that weird dynamic?
Well, I think, in the case of the International Energy Agency and the CPS scenario, the carbon profit scenario, we call it, that they released this morning, it is described as a kind of explanatory scenario, but in fact, it's normative. It's a normative scenario to please the fossil fuel system in the same way as the net zero scenario was a normative scenario to please the green warriors. These are both normative scenarios to sort of cater to particular group of stakeholders. You want to maximize the profits of the fossil fuel system? Great, go for the CPS. You want to deal with reality? Look elsewhere, please.
Yeah, but it's not just the IEA. It's the EIA does it. Even a lot of big private consultancies and research firms, it's a culture almost in the analyst community that they refuse to accept the good news here. They refuse to believe the good news in front of their eyes, and they keep thinking it's going to end.
Again, as you know, David, the reason why it's not rocket science. When you're paid by the fossil fuel industry to come up with their scenarios, then you are going to come up with very conservative scenarios. And that's what has been happening right across the board. And I think what the IEA had been able to do for the last 4 years was to kind of crack open that story and tell the truth. It's been fantastic. And, of course, they're still doing great analysis in lots of different areas. But, the baton, I should say, has now been taken up by other folks who can see a much more optimistic future.
Yeah. A couple of individual questions about this learning curve dynamic. One is, I think when I talked to you in 2021, you included electrolyzers in your sort of list of electrotech technologies that are on learning curves. But then, when I talked to Michael Liebrick a while back, he was kind of poo-pooing electrolyzers, saying they're not actually falling in price, they're not actually proceeding. So what's your take on electrolyzers, whether they're on a learning curve, whether they're part of this electrotech package, and I guess more broadly than sort of hydrogen too?
We don't get everything right, David. I think 4 years ago, we too were more enthusiastic about this stuff. And we felt that they would get onto learning curves, but it turns out that they, as Michael himself has said, whilst the electrolyzer is small and modular, all of the kit around it is not.
Mm.
And therefore, we haven't seen that learning curve effect. We haven't seen inherently within hydrogen, you don't have the same levels of efficiency as you do in all these other electro technologies. So I think we've kind of been happy to move on from that, just focus on the stuff that's working.
So you like Michael have downgraded sort of your expectations for hydrogen and hydrogen technologies in this whole package.
Yeah, look, I think there's something really important to be said here. And we all got slightly, myself included 4 or 5 years ago, we all got a little bit gaslit by well, not so much for the hydrogen industry as by the incumbency. The incumbency telling us we have to figure out how to solve the last 10%.
We need a liquid fuel. We have to have a liquid fuel.
And, the answer is, like, where else in your life do you try and figure out what you're going to be doing, on a Tuesday in 25 years' time? Of course, you don't figure that one out. You just get on with your life and you try and look for the next 5 or 10 years. The Chinese have this famous saying, crossing the river by feeding the stones. And that's absolutely has been and will continue to be the right solution. Is we need to figure out where we can deploy these technologies at speed and scale with reasonable cost and do it with massive scale. And the more we do it, the better we get at it. So, we had this other little piece in the report saying that the ceiling of the possible is now basically at 75%. And we're at about 20% electrotech. So who cares about the last 25%? Put some of your brilliant scientists onto it, and they can figure it out. But in the meantime, the vast majority of our time and our talent and our force and our genius needs to be poured into getting from 20 to 75. And by the time we get there, we're going to be aiming for 95.
Yeah, this is the baffling thing about Bill Gates' recent intervention in this whole thing is he's still on that, which feels like vintage, like 2018 to me. Like he's still on that, like, oh, we got to figure out the last 10 to 15%. It's just like, can we just do what we know how to do? Can we just do what's right in front of us? Like, we'll figure that out in the process.
Poor Bill. He's obviously much richer than I am, but he's not very good at energy, and he's vastly influenced by the sort of fossil apologist Václav Smil, with his ridiculous book, How the World Really Works.
Yes. And
what does Václav do? He takes these 4 sectors, the last 25%, and says, because we can't solve that, there is no energy transition. And, the analogy is a bit like saying in 1900, because I can't fly to America, you can't drive a car. Well, no, of course you can. You get there eventually.
One other question about technologies and learning curves, which I didn't see talked about much in the report, and I just kind of wanted to ask about, is grid forming inverters. I guess that's more of one of these digital software products than a physical product technically, but I just didn't see a lot about them in the report. I wonder if they're on your mind and if they are also getting cheaper, or whether you guys have done much thinking about them.
We love this stuff. I mean, like anything. No, we love all these technologies, these sort of clever technologies in the middle. And again, whilst it may be a 110-page deck, that's also quite small for the entire system. And we are planning to do much more work, actually, for what it's worth, on these technologies in the messy middle. Because the whole point is that it's going to unleash this cornucopia of innovation to enable people to figure out solutions in lots of different ways. So yeah, grid forming inverters are a fantastic solution to enable you to solve some of the very specific problems. I remember being beaten up 10 years ago by my ignorance about not understanding, all these kind of issues. And thank goodness somebody's come up with some answers.
Yeah, and just on that, like the whole idea that giant multi-ton, constantly spinning masses are going to be preferable to basically what is a little computer has always amused me. Like, this is so obviously a step up. Anyway, so, okay, the first fundamental driver is physics. These technologies are more efficient. The second driver is economics, in that these technologies are all getting cheaper while fossil fuel prices more or less stay the same, which means their economic triumph is more or less inevitable. Like, we're in kind of a fuzzy spot right now where, like, individual electrotechs are sort of passing up individual fossil, applications in individual places. But, like, in the fullness of time, these lines are all moving in one direction and fossil fuels are all staying the same. So in the fullness of time, these are going to win on economics.
Yeah, I mean, they're going to win. And I think the other really obvious point to make is, and this is why I find it so funny, you talk to people being very, very expert at I don't know, gas in Malaysia or something.
Right.
And then here's 100 reasons why your ideas are wrong. And you just go, look, just stand back for a second and think about this from a system perspective. All that's happening here is economics 101. You've got a giant cheap source of energy coming into the system. I don't know exactly how it's going to play out. I don't know exactly where it's going to end up. But all I do know is that it's going to drag down the cost curve. And therefore, if you are at the top end of the cost curve and think that it's going to stay there, the LNG industry, for example, forever, then you're going to be very, very profoundly disturbed by the reality of all of this cheap energy coming into the system. And it will find a place.
As the report says, as we keep saying, this is not some arcane secret knowledge we've developed. The graphs are right there in front of them too. Like, you know what I mean? The graphs with the line pointing down is right in front of them too. I don't know what they think is going to happen between now and 5 years from now that stops that line from going down. But like, this is all very foreseeable. So anyway, the third fundamental driver, we got physics, we got economics. The third one is geopolitics, which I think, and maybe you agree, is like such a vast, huge topic. So much is going to happen and we understand so little. And I feel like less able to predict this kind of thing than almost any of these other areas. But the one thing we know for sure, just talk a little bit about the balance in the world between fossil fuel exporters and importers. I think that's a very basic fact that people need to understand. Hey there, everybody. Don't worry, I'm not going to tell you about a new mattress or push a credit card on you. This isn't an ad. There are no ads on Volts. It is supported entirely by listeners like you. If you'll indulge me for a second, I'd like to ask for your support. I started Volts because we're all surrounded by depressing news about climate change and misinformation about clean energy, and it's never been more important to share the stories of the real people on the ground doing the real work of transition and all the ingenuity and courage and public spirit they are bringing to it. People are hungry to hear these stories, to learn from and find inspiration in them. I've heard from people who change majors or careers after hearing episodes of Volts, people using it in classrooms and community groups, even state legislators who have passed bills inspired by specific episodes. Sharing these stories matters. It makes a difference. If you have found value in it and want to help me continue doing it, I hope you will join the community of paid subscribers at volts.wtf. It's about the cost of a cup of coffee a month. If you don't like subscriptions, you can make a one-time contribution, leave a review on Apple or Spotify, or just tell a friend about Volts. I am grateful for any and all support. If you're already a paid subscriber, thank you. And now, back to the show. Just talk a little bit about the balance in the world between fossil fuel exporters and importers. I think that's a very basic fact that people need to understand.
The starting point here is that 3/4 of people live in countries that import fossil fuels. And that means Europe, famously dependent for 60% of its primary energy on imported fossil fuels.
Right.
It means China, where it's about 20%. It means India, about 30%, much of Southeast Asia, and actually very large swathes of Africa and South America as well. So most people in the world are importers of fossil fuels. And under the Pax Americana, 80 years since the Second World War, that was kind of fine, right? Americans, thank you very much, protected the seaways, and we could source from lots of different places, and it was all fine. That whole framework really started to break down after 2022, and particularly after President Trump starts to weaponize fossil fuels in 2025. So, the fossil fuel folks in the US thought they were being brilliant, but actually you should be careful what you wish for, because what have you done? You've just panicked the rest of the world into thinking, okay, enough's enough. We need to get our own energy.
We think we have them over a barrel, but we don't. They have alternatives. Now, I think this has not sunk in perhaps with the Trump people. Like, if you squeeze these fossil fuel importers hard enough, they're going to look around for alternatives.
And that's precisely what's happening now. So, you show up in Europe, you force the Europeans to sign this $750 billion deal.
Oh, Jesus.
And whatever it was, what do you think they're going to do the minute the door is closed? I mean, do you really think that they're going to do nothing? Of course they are. They're going to desperately, all across Europe now, people are like, right, we have to electrify.
Yes, we cannot ever again be in the position of being basically bribable, manipulable like we have been in the last decade.
Yeah. The famous analogy being that I always think of is the 12 young men and women that were sent to the Minotaur to be eaten alive every year until Theseus saved them. I mean, this is how we feel in Europe. It's just really aggrieved. And you can see, the Indians feel exactly the same way. And every Indian will tell you that country imports $150 billion a year of fossil fuels. And anyway, the point is that this kind of fossil dependency was okay in the past, not great, but okay. And now it's not okay anymore. And people are looking for solutions. And, it's highly complex geopolitics. And, there's lots of great work done, for example, by T.S. van der Graaf on this whole issue at the Brussels Institute of Geopolitics, just identifying how people are going to change the way they operate for this new world. And anyway, this then sort of brings us on to, okay, why is electrotech the solution to this? And the reason it's the solution is because everyone has got, well, everyone, I should say, apart from Singapore and Belgium and a couple of other countries.
Arctic Circle, I don't know what their capacity is.
But everyone's got a huge amount of renewable potential. So, if you focus your renewable potential on the easy to solve areas, you strip out farmland and forests and cities and lakes, everything else, the place you don't want to put these solar panels, and sort of focus on wastelands and low quality land. We have 100 times as much renewable potential. So the great challenge of this generation is to figure out how to bring that to bear. And actually, there are two ways of doing it. The first is to put up the solar panels and the wind turbines and stuff. But the second, and actually the one that people have really not focused enough on, is to electrify everything. And it's the electrification angle, which has really stagnated in the West since 2008. And we got leapfrogged by China, but we've also been leapfrogged by Southeast Asia. There's a massive electrification story going on all across Asia. And, here we are sitting in England, twiddling our thumbs, fiddling around and failing to do it.
One of the sort of counter arguments here, which is a little bit glib, but we should probably address it, which is some people say, well, you're just trading dependence on fossil fuel producers for dependence on China. China's the one manufacturing all this stuff, so you're just shifting your dependencies. Why is that wrong?
So I wonder if this argument could possibly be seeded by our dear friends in the fossil fuel sector. Look, the main reason why this argument has absolutely no merit is that it's the difference between renting and buying. So if you buy a solar panel, you've got it for 30 years and you can use it and you can generate electricity for 30 years. If you rent a barrel of oil, you burn it the next morning and then you have to get another one the next day. And therefore, think, how scared you feel in certain jurisdictions as a renter versus owning your own house. That's the difference. That's the fundamental difference between the two. But actually, it's even better than that, because China does indeed dominate solar panel production and battery production and minerals refining. But if you extend and look more widely at the electrotech sector, you actually discover there are lots of areas where other countries play a huge role. So if you take, again, this messy middle, most software, actually, if you look at stats coming from the US, the Germans sell more cables than they buy solar panels. The Japanese make transformers. I mean, there are lots of pieces inside the system that other countries can get involved in making. And furthermore, it's a challenge. It's a challenge to all of us. Stop moaning about the fact that you're not making this stuff and make it. I mean, there's no one stopping you.
You can't just choose to dig up fossil fuels if you want to, right? You can only dig up fossil fuels if you're sitting on top of them. But any country can decide to make this stuff. I think also one of the things people miss, which is a very intriguing bit in this report, is that China is not just exporting these technologies, it is also exporting the capacity to manufacture these technologies. And so then you're not, I don't even know what the analogy is with the renting and owning, but then you're buying a house building company, and then you're really not dependent.
Yeah. And so there is this famous number that Chinese FDI on electrotech is $200 billion, which is the same kind of size as the Marshall Plan. And there are these fantastic maps of Chinese built fabs being built in Hungary and Vietnam and Uruguay and Chile and all over the world that, they're putting up fabs so that people can make it for themselves.
Someone linked it on Twitter. It was in a Chinese catalog of some kind where you could literally just click to buy a solar panel factory, like a modular solar panel factory, which is what's very mind-blowing to me. So just like the manufacturing of these things is only going to get easier, and any country can do it. And as you say, I don't know, forget the exact statistic in the report, but something like 92% of countries in the world have like 10x the renewable potential of their current demand. So this is like, there are not a lot of limitations here. So you can see a world, you can imagine a world where all or most countries are energy self-sufficient. And that is a fundamentally new state for humanity to be in. Like, we've never experienced anything like that. The energy flows and energy dependencies have shaped human history and society and politics from the jump. So like, a whole new chapter of our time on this earth, I feel like we're entering, and we have no idea really how that's going to play out. Very interesting to watch.
It is interesting. And, we are blessed to be alive, as it were, at the moment. And I think, the other point you're touching on it is the real opportunity, in fact, lies in the Sun Belt. For the 80% of people who live in countries, within a reasonable distance to the equator.
Right.
So the 80% of the global population. If you live, sadly, England's not one of them. But anyway,
I looked at the map of renewable potentially, and like middle of Europe is sort of like the lowest. You guys kind of got screwed there. It's like the lowest renewable potential.
All it means we have to work harder, as I say. But the point is, it's actually a profound driver of justice and opportunity and growth and development for the people of the global south and the emerging markets who don't have or don't use a lot of energy right now. Suddenly, they can harness and store sunshine, and that's got to drive development, because of course in the old fossil fuel punctiform world, wealth and power went to the small number of countries, the petrostates, 5% of the global population, who were fortunate enough to sit on these massive fossil fuel deposits. And it's been great. That's why they can build skyscrapers a kilometer high. But that's, folks, where all your money's been going. That's $2,000 billion a year of free money going to build this stuff, and now that's going to come to you. And you could get your own energy. And how cool is that?
Yeah, I know. So let's talk a little bit about China and its role here. It seems like specifically what people don't see coming is road transport, specifically in China, is getting at what you call the soft underbelly of oil demand. So just talk about China's role here, what it's doing and what its effect it's having on global markets.
So the thing about China is doing this not necessarily, I should say, for the sake of the planet, but for the sake of their own interests, obviously, like most other countries. And they, 10 or 20 years ago, identified an opportunity in leaning into electrotech, and it's paid off. I mean, of course, there was no guarantee 20 years ago that it would, but it has paid off. And you really see this since 2008. 2008, China and the US and Europe are all running neck and neck in terms of the electrotech patents. Now, China completely dominates 75% of patents. They are these very high shares of manufacturing of these technologies. Again, we would go on and on, but possibly the most interesting story is that China is electrifying while we are not. Electrifications in the West is stuck at just over 20%. China's electrifying at 10 percentage points a decade. So, they're now at 30, they're heading for 35. And as a result, they're kind of reaping the benefits, the geopolitical benefits of being able to, sell these technologies abroad and so on and so forth. And the reason we say this is because it's not an option to do nothing. China is inventing technologies which will make them stronger and stronger because they're more efficient and superior to burning stuff. And ultimately, if other countries wish to compete with China, they are going to have to get involved. I'm looking at you, America. You can't just sit around burning, limited supplies of shale gas and hoping for the best. I mean, this incidentally is another reason why I'm very optimistic. The tech bros absolutely get this. They get the fact that electrotech is a tech story. They know what to do. They're doing it. AI is an electrotech solution. And actually, the great thing about America is that eventually it always gets to the right answer. So, I can be very, very confident that, led by, folks in California and other states, that this will happen in the US too.
Yeah, I mean, the Trump people seem to be very taken with these forecasts, which you often see these days, which basically say like fossil fuel demand is going to be strong and robust out through 2050, 2060, 2070. You see these. I think that's what they're banking on. They are just sort of like, even of a shrinking pie, we have the biggest piece. and that will bring us prosperity for the next several decades. I think that's a disastrous gamble to take. I suspect you agree.
Yeah, look, I mean, again, as a kind of professional analyst, it's pretty easy to identify the errors that are being made in these models. I mean, the biggest error is, and I can critique actually the latest model that just came out from the IEA called the carbon profit scenario, the CPS. Solar and batteries have been costs have been falling at like 10 to 15% a year for decades. And then suddenly they stop falling. The annual cost falls drops to about 3%. So that's the first error they make. Suddenly cost falls are going to stop. And then the second error they make, and as ever, is that the growth stops. And then the third error they make is they go, well, okay, I get that I can't block the Chinese, sadly, and the Europeans haven't got any fossil fuels, but fortunately I can force my LNG and my oil onto these folks in the emerging markets. They have to take it. But guess what? They don't. And they're not. And you're seeing this incredible leapfrog. 2/3 of the emerging markets have leapfrogged America in terms of solar as a share of generation. It's crazy.
Let's talk about that briefly. That's a good segue from China, because part of the China story, or I guess sort of like a piece of the China story, is these other emerging markets, non-China emerging markets. So always the big worry is China developed on the back of coal, famously.
So did the UK, and so did America.
And so did UK, and so did everybody so far. So the worry has always been that these emerging markets are going to follow China's pathway, basically. And if they did that, we're all screwed. So there's been hope for years about leapfrogging. Like, I'm sure you've been hearing the term leapfrogging, decades now. And it really seems like it is actually happening. And it's mainly happening because China is overproducing all these electrotech technologies and making them extraordinarily cheap, and they're just leaking out into, like, I did a pod with some guys in Pakistan where, like, they've imported 40% of their total country's demand worth of solar panels in 2 years. And as you say in the report, like, that's happening in a bunch of these markets.
Yeah, I mean, it's actually far more prevalent than people realize. 2/3 of the emerging markets have already leapfrogged the US in terms of solar as a share of generation.
So that means solar is a bigger chunk of their total generation pie than it is of the US.
Yes.
It's 2/3 of emerging markets.
Yes. Now, that's 2/3 by demand. So not by number of countries. Actually, by demand is even more powerful. So, I'm talking about India and Brazil and Mexico.
Vietnam.
And Vietnam. And I should say, I don't really see the driver as, the Chinese overcapacity leaking out. It's more that Chinese cheap stuff, and these guys are buying it because it suits them. So that's going on in solar, and there's no sort of ideological commitment against solar. Why would you? I mean, it's sunshine, right? But actually the other one, which is even more interesting, arguably, is this kind of electrification vector, that people are electrifying their industries, electrifying their transport systems. US has got EV's share of sales around 10%. Like Vietnam is 30%. Nepal, if I take the kind of export stats, is like 75%. And, this wasn't meant to happen for decades, that the emerging markets, leapfrog to these superior technologies. And the reason they're doing it is not because, it's just because it's cheap, right? You can buy an electric car for $10,000. You can buy a solar panel for $50. I mean, why wouldn't you?
So do you think the consequence of that is that, as you say, U.S. is betting on LNG exports? That's kind of like, that's the fossil fuel industry's big bet in the U.S. right now. They are betting that these emerging markets are going to need LNG. And furthermore, they're trying to tell us this LNG is cleaner than the coal the emerging markets would otherwise be burning. You think that electrification in emerging markets is going to basically moot that story? And consequently, do you think there's going to be a bunch of overbuild and stranded assets in the LNG market?
There's a very obvious battle of overcapacity between LNG and solar right now. So the US industry is tooling up for 300 BCMs of LNG exports. Chinese are tooling up for about 1,200 gigawatts of solar exports. And incidentally, for what it's worth, that's actually, those two numbers generate roughly similar amounts of electricity. Only the difference is the Chinese one does it in year one, and it does it for the next 30 years. But the point simply is that it's a battle of overcapacity between the two. And so just simple economics, the break-even level that you require to make LNG projects work. I mean, it depends which one it is, I guess, but let's call it around $10. $10 per MMBTU is $80 per megawatt hour electricity in Vietnam, and you're getting at 50 already today, and you stick a battery on top and it's 70, and by 2035 it'll be 40.
Yes, as we keep saying, these arrows are all pointing down. So like whatever it is now, it's less than that 5 years from now, less than that 5 years with the hints.
Yeah, and the IEA kind of says, well, okay, fine. What that means is you're just going to have very, very cheap gas going out there. So what that means, then for the people producing it is they're doing all of this stuff for nothing, really. Thank you very much for pouring billions of dollars into, this kind of export capacity, this highly complex technology where you're not even going to benefit from it. Again, it makes no sense. And I think the tragic thing here really is that these are basically the last hurrah of the fossil fuel system. And what is the point in doubling down on the technologies of the last millennium when you could be dominating the technologies of this millennium?
Well, I mean, in a perverse way, the fact that we've fallen so far behind on electrotech, people are using that as an argument for why we should double down on LNG. Like, hey, China already dominates this stuff. Let's do what we're good at. But like I said, I don't think that's going to work out long term. So you mentioned already that 3/4 of total energy demand can now be supplied by electrotech. So we know how to do transport. We know how to do buildings, basically building, heating, and cooling. I mean, this has been one of the fun things about the last decade or two is just watching electricity conquer things that a lot of people confidently said it would never conquer. And it's just sort of like moving up the ladder, doing things people said it couldn't. And consequently, you're seeing peak fossil fuel demand in various industries, various sectors, various countries. And you make a lot of this in the report, these various peaks. So talk about sort of like these local peaks we're seeing. Like it blew my mind a little bit that global fossil fuel demand for various things has already peaked. So go through a little bit like what's peaked and what hasn't.
Yeah, so look, I think here it's quite interesting. What we've done is not very sophisticated. We've just taken the International Energy Agency's World Energy Balance database, which is incidentally behind a paywall, which I guess people don't do it. But it's not very sophisticated. We just take a look at that data and we just split the energy system to two parts, making electricity and then using electricity, final energy, they call it. And then we just take a look at what's going on. And, in the making of electricity, you've got kind of solar wind growing. And it's kind of obvious if you continue to extrapolate this growth that at some stage they'll supply all the growth of demand. And that moment was the first half of 2025 when global electricity demand grows about 380 terawatt hours and solar and wind alone were 400. So in the biggest sector of fossil fuel demand responsible for 40% of fossil fuels, electricity, we're basically at the peak right now. I mean, again, these peaks are kind of, things can happen. You can have an outage of hydro in China and nuclear in France, and you can get bounces. But like we're there or thereabouts in the electricity system. And then when you look at the three pieces of the final energy demand, which are buildings and industry and transport, the three biggest pieces, I should say. I'll come on to the other piece, which is petchem. But three biggest pieces in buildings, just go and do the math. It's basically a 2018 peak. We haven't grown really since 2018, fossil fuel demand. In the industrial sector, not widely appreciated, that in energy for industry, that is to say, not with feedstock, which is petchem, you've got a 2014 peak. We've plateaued since then.
This is one of the things people hold out as like one of these difficult to decarbonize sectors. This is something like Bill Gates is always talking about. All these people who are electrotech skeptics hold out industry as sort of like, but what about industry? But as you show, like globally, fossil fuel demand in industry generally peaked in 2014.
And the reason why it's not rocket science is just China stopped massive build out of its energy intensive industries and commenced electrification of its light industry. Mm-hmm. And this is what people often forget. It's like, people love to obsess about, the hardest to solve, last 20%, that bit of steel, whatever it is. But, how about all of the textile industry and the pulp and paper industry, the machinery industry, and the food industry?
Yeah. I did a pod recently on those sort of like mid-temperature, mid-sized, industries. It's just big heat pumps. Like we know how to do that. So,
I mean, again, in our little calculation, we're a clear peak in 32% of end industrial sectors because the IEA disaggregates into about 15 separate ones. 32% you had a peak, about 60% they're on a plateau, and then 6% of sectors have got a little bit of growth still coming through. But that's the industrial sector. And then you look at the transport sector, and the transport sector is particularly interesting because people are always like, oh, you can't possibly decarbonize flying, and flying to Australia.
Yes,
can't do
they do say that.
Yeah, but flying is not the largest piece of the puzzle, folks. The largest piece of the puzzle by far is road transport. And we are decarbonizing road transport such that the latest data that came out this morning from the IEA suggests that there is no growth left in road transport for oil. The largest piece of the puzzle has reached a peak and is going to start to enter into decline. I mean, it takes time, right? These things last 15, 20 years. So,
I found the quote from your website. Fossil demand has been flat for industrial energy since 2014, for buildings since 2018, for road transport since 2019, and may peak for electricity this year. So these peaks are not in the future. They are happening. A lot of them are already in the past. And one of the things that I remembered about our first conversation is you talk about the business dynamics that apply to an industry that is in decline, which are very, very different than the business dynamics that apply to a business that is expanding, even if the total amount, you know what I mean? Like the amount you're using the year before the peak and the amount you're using the year after the peak are pretty close to the same, but the dynamics shift dramatically. So just talk a little bit about like what happens to an industry when it is past its peak.
Look, we don't need to look very far to come up with a classic example of what happens. Look at the US coal industry after 2014. So if the US coal industry basically tools up for growth, borrows for growth, builds for growth, analyzes for growth. All of their analysts were talking about growth coming forever, and it doesn't come through.
Yeah.
And you get minor decline. And within like 2 years, half the industry's gone bust. And within 5 years, the industry gets delisted from the S&P completely. That's what happens, folks, to capital-intensive industries dependent upon continuous growth. So this was the inspiration, as you know, for Carbon Tracker. This observation that as capital-intensive industries, and this incidentally is the difference between fossil fuels and tobacco. Tobacco is highly capital unintensive, and it sells its products to consumers. Fossil fuels are highly capital intensive, and they're competing with a superior energy source. So it's very, very different. And once these capital intensive industries reach a clear peak and struggle to get any new capital because people can see the writing on the wall, then they go very rapidly into very significant shock. And that, incidentally, is one of the reasons why the fossil fuel industry has been fighting so hard to obscure what's going on, because they want another 5 years or another 2 years. Just give me another 5 years, another round, another couple of bonus rounds that I can retire and, good luck.
Yes, and you see investment in that industry starting to shift toward dividends and basically like enriching executives and shareholders while they can. There's a little bit of a like, let's party while we can vibe happening happening in that industry. So do you think like 5 years from now, these peaks will become visible enough that these sort of like, some of these are like almost mechanical economic consequences, but there's a lot of psychology here too, as you say, like just the investors' disposition toward an industry that's not growing anymore is very different. So do you think that's going to be visible and obvious to everyone like soonish?
I guess the whole point about peaks is that they're not particularly visible at the moment. I mean, famously in financial markets, nobody rings a bell at the top of the market.
Yes.
But it's not really that hard if you assume continuous growth of the new, then inevitably, first of all, takes growth and then pushes the old technology down. I mean, that's been the story, not just in energy, but in every sector, in our own experience, for decades and decades and decades. So it's totally normal for the growth of the new to push the old one out. And I think because it's bumpy and choppy and there are lots of variables involved, at the moment, it's a little bit hard. By 2030, however, when you've got over 1,000 gigawatts of solar coming onto the system every year, when you've got basically 90% EV penetration in China and very high EV penetration across the emerging markets, I mean, at that point, it just becomes harder and harder to sustain this argument. And I think this is, again, where we bring a little bit of market savvy to the debate. It's like, okay, at the moment, it is slightly debatable. But by the end of this decade, if these growth trajectories continue, it'll be undeniable. I should also say, David, this kind of framing that we have of peak and then decline, we're not picking it out of thin air. I mean, it's exactly what's happened in country after country. Like, go and have a look at the numbers, folks. Germany and the United States as well, for what it's worth, Brazil. These are countries where fossil demand like peaks decades ago, and then it does start to decline. And this is completely normal. And, from our calculations, half the world's past peak fossil demand in electricity generation, 2/3 in final energy demand. The only country which was kind of holding up the sky for the fossil system was China, because China was so enormous that, they had continuous growth in fossil fuel demand. 95% of the growth since 2018 on a net basis came out of China. And that's why the fact that China, you're getting more and more signals, as we've been hearing on your show and others, that Chinese fossil fuel demand is peaking because of the huge amount of solar and wind they put into the system and the electrification of transport. That's a big moment. It's the pivot moment in the system.
Mainly the road transport thing. Is the huge growth of EVs in China that is the body blow, really, for global oil demand.
Yeah, and of course, coming through to trucks now, these famous stats now, 20% of trucks. And, you and I both been in this game long enough to remember the people who are, will never happen in trucks. Well, guess what? This is a very similar story to the car story. You start small, gets big.
One of the questions everybody has about all this stuff is there's been big political reversals in the U.S. You probably noticed. And not only in the U.S., I mean, really like sharp 180 reversal in the U.S., but not only that, like there's kind of been a pall cast on the whole thing. Like the U.S. is now in UN meetings about international treaties, bullying other countries not to sign them. They're bullying other countries into taking our LNG. So there's been a real distinct pivot in the U.S. How highly do you rate that as a risk for electrotech? Like, do you think that is going to, stop anything or slow anything down?
No, no. I mean, look, this is the tide. You can, like as King Canute found out, 1,000 years ago, you can't stand in the way of progress and tell it to go back. Maybe they could have done this 10 years ago, but it's just too late, folks. And it's very interesting to substantiate that point. So take the recent forecasts, made again by the IEA. So they downgrade the forecast for solar and wind deployment in the US by whatever it is, 40 gigawatts a year. But they upgrade the number for Asia by the same amount, 40. They downgrade US EV sales. They upgrade emerging market EV sales. I mean, it's a messy story. But again, you've got to step back for a second. I think all of us as conditioned, myself included, to look up to America. Imagine America leads in everything and you just copy America, you do well. Yeah. Copy California is always my mantra. But in this particular instant, at the moment, for a while, it's been China leading. Like China's 50% of everything, 50 to 80% of everything. And the United States about 10%. So fine. So the 10% of the system, for a few years, and of course, it's not all of the 10% because you've got, of course, in the US, you've got states and cities and individuals who are doing it anyway. But anyway, for that 10%, which was aspiring to China, and it's not going to China for the next 3 years. Okay, it's a shame. But, the Chinese aren't sitting back and saying, oh, that means we're not going to do anything. On the contrary, the Chinese are pouring their technology into the emerging markets.
This is just an enormous, we're just leaving the playing field, right? I mean, they must be just like cracking the champagne and high-fiving in party headquarters there because we're just like letting them. We're just stepping out of the way and letting them dominate this stuff.
It's a great shame for the US and, for us in Europe as well, I have to say. But the game's not over, right? I mean, we're at 20% electrotech in the system. And, we're in a marathon. And as many people have said, and we're a few miles into the marathon, but you don't just give up because your competitor's a few hundred meters ahead. I mean, there are lots of innovation going on everywhere. The Chinese don't have a monopoly on genius. America's got lots of universities, so is Europe. And, there's lots of ideas coming out from all over the place. I think it's absolutely worth engaging with this story. And we're going to have to get to terms with it, like it or not.
Final question. Let's talk a little bit about AI because this is on everyone's mind. And there are sort of, I guess, two stories to tell about AI. One is AI itself and how it becomes part of electrotech, as you said earlier. And I'd love to hear your thoughts about that. And then sort of the other side of the AI story that we're always hearing about is the massive spike in electricity demand, which a lot of people in the US are worried is going to prompt a dash for gas. It seems to me like that's the easiest thing for these utilities that are lazy. You know what I mean? If you're lazy, that's sort of the easiest thing to do because like all the systems are set up. So I wonder on both sides of that what your thoughts are about AI.
Let me state it boldly. AI is an electrotech solution to match supply and demand of electrons. And it is the electrification of thinking, and it is a tool to enable higher levels of electrification. That is, for me, the starting point. So AI is great, and it enables stuff to happen. And specifically for electrotech, because it's only AI that can match the supply and demand of electrons in real time, it is for us a key way to solve one of the most complex problems facing humanity. So great. And of course, doing lots of other great things too, but let's focus on that for a second. So when it then comes to this second argument, I find it really bizarre because it's completely data free. If you look at the expected growth of AI demand to 2030, it's 10% of the growth in global electricity demand. It's 50% of the growth of electricity demand in America. So I get it's a really big deal in America because electricity demand is very low. It has been for since 2008.
Yeah.
So it's a big deal in the US, but it's not a big deal at a global level. It's 10% of the growth. It's smaller than space cooling. It's smaller than appliances and fridges and stuff. Because it's not to belittle it, but it's just incredibly efficient AI. You get an awful lot of stuff done, for a click, which is why we use it all the time. And then the other point that people are kind of obsessing about how much gas it's going to use. So, we went and we did the math, and it's like, okay, it's about 200 or 300 terawatt hours of gas will be used for AI. Well, global gas demand's 8,000 terawatt hours. So we're talking about 3% of the gas. So of course, if you're in Ireland or, North Virginia, it's a very big deal. I get that, but it's absolutely irrelevant to sustaining the fossil fuel system. And actually even more exciting, and this again came out in the report this morning, the IEA calculate that you need about 500 terawatt hours, so that's about 2 exajoules of electricity to run AI, and you're going to get about 13 and a half exajoules of savings from it, particularly in the industrial and transport sectors. So there you go. It's a 6-to-1 reduction in energy demand coming out of using stuff more efficiently as a result of AI. And that number, that 13 and a half is a number that everyone's been sort of hunting for. It's a kind of holy grail. And Amory Lovins wrote a very brilliant paper making exactly this point several months ago, that AI was highly likely to result in more efficiency gains than it was going to take in energy demand.
But that's a little bit of a guess, isn't it? I mean, that's a little bit of like an educated guess. Like, we have no idea
we have no idea, but do we have any idea how much, where does this number come from for 500 terawatt hours of electricity demand? I mean, look, that's the other point. I'm sorry to be boring, but, look at Kumi's law. Dramatic potential for reducing the amount of energy demand per unit of processing power. I mean, there's incredible numbers coming out. It's like 33 times, I think, is the number Google talks about of improvement in a single year. So it's been a wonderful hype story, but I think we can now claim AI as an electrification technology. Thanks very much, folks. And now let's just get on with it.
So you think the AI's contribution to spreading electrotech and making it more efficient is going to just vastly outweigh whatever new fossil fuels it pulls onto the grid in the short term?
Yeah, well, there you go. In terms of the numbers, in terms of like the total demand, it's 6-to-1. But of course, gas is only, let's say, 200 out of the 500 terawatts. So it's like we're already talking 14-to-1. But call it 14 times as much or 10 times as much reduction in energy demand as you're going to have in supply. And again, it's not surprising that, we kind of been worried about it. And we should be worried about it. We shouldn't, just do this stuff without due care and attention, so on and so forth. But it's because we count what we can see. We can see these vast data centers going up. I mean, there must be a huge amount of electricity demand. But actually, when you can't count all of the reduction that's coming through.
Yeah. It'll be interesting to see how those numbers balance in coming years. All right. So I've taken way too much of your time. We've gone over almost everything. Just as sort of like as a way of taking us out, I wonder sort of like, we've talked about all these little mini peaks that have happened here and there. What do you think is going to be the next headline moment you're anticipating? Is it a clear peak in global fossil demand for electricity? Is it a clear peak for China? Is there like a news event that you're looking forward to that's going to be sort of symbolic of what's happening?
Wow. It's a very good. I think that China peak, because we get very frequent data on China. And it'll be pretty clear.
Total fossil demand
in China, because of course they have this official target of 2030, and as everybody knows, the Chinese tend to hit their targets 5 years early. So I mean, that's very, very low quality analysis, but it's also substantiated by all the data coming out of China saying that coal demand in China is down year to date by 3 or 4%, and the coal demand in China for electricity, to be clear, has been responsible for the vast majority of the growth in energy demand over the last decade. Since 2018. So I think peaking demand in China, clarity on peaking demand in China will change the debate, because people go, okay, I get it now. We had a peak in the OECD in 2007, peak in China in 2024 or 5, and then it's going to reverse. It's like, okay, great. Who's next?
Those are the two biggies.
Those are the two big ones, because those two together will, as they decline, will outweigh any residual growth coming from those small parts of the emerging markets which are still growing.
Yeah. And this is maybe like a slightly quasi-technical question, but is there an agreed, like, how many years of falling demand is enough to convince analysts that we've passed a peak? Is there any shared answer to that question, or is it just like a judgment call?
Well, I think ultimately it's going to be financial markets. Actually, that's where you're going to see it first, where you start to see some of these sectors falling out of bed, and then it just sort of filters its way through to public consciousness. Like, okay, yeah, we've got it. These sectors are over. I mean, traditionally and famously in financial markets, you don't wait for the peak to be clear. You act before, clearly, because you want to get out before the top. So I think it's financial markets you'll see this. And that's, incidentally, I mean, one reason why people need to pay attention right now, because obviously it's very surprising. There was so much geopolitical tension out there. The price of oil is still relatively low. And, when you start seeing it coming through in stock prices and surprising things happen, and M&A taking place, which you wouldn't necessarily expect because companies far weaker than you think they are, that's a kind of classic lead indicator.
Yeah. When the Titanic deck chairs start being frantically rearranged, that's our signal. Kingsmill, this has been awesome. It was awesome the first time. It was awesome this time. I'd love to have you back in 5 years, and we can once again wallow in all the delightful progress. It's always a thrill to talk to you.
I will take you up on that, David. Assuming we're still going, We should do it.
Thank you for listening to Volts. It takes a village to make this podcast work. Shout out especially to my super producer, Kyle McDonald, who makes me and my guests sound smart every week. And it is all supported entirely by listeners like you. So if you value conversations like this, please consider joining our community of paid subscribers at volts.wtf, or leaving a nice review, or telling a friend about Volts, or all three. Thanks so much, and I'll see you next time.